Hello everyone. Continue the continuity lessons. Last previous lessons, we lead the function we want to check is continuous or discontinuous. But we're doing by leading from the graphs, right? And for example, like when we have like this one, right? If they have like a one open dot, you're gonna say this discontinuous. Or even, for example, this like graph, right? So when we leave for this one, when you see the open dot, we always say this is a discontinuous, or maybe we have another graph somehow, something like this. Okay, maybe like this, a graph, right? So then you're gonna say this one is what? Discontinuous, because we use the continuity informally when we lead, right? Like from this point jump to this one, and then you can say, because we have to lift our pen or pencil, then this one gonna be discontinuous functions. But now if go to the continuity formally, that means we have to show the work, to write the work, how this each question is continuous or discontinuous. So now this is the one we're gonna show the work if the question requests to show the work. Okay, so first of all, you see the definition of this one. Okay, they have the 3 steps, right? First one, okay, see the definition first. Let's f the function, right, be a function that is divided for all x in some open interval containing c. Then f is a function is said to be continuous x equal to c under the following conditions. They have 3 conditions, or so you can say it's the 3 steps you have to write down. So first one again, f of c is divided. Okay, that means the function of when x equal to c is divided, that means you can find the value of functions. Second one, limit f of x when x approaches c. See that? Same c, okay? If there exists, that means the first step and the second step, if they are equal, then you can say like a number 3, you can say first step equal to second step. Then you can say this is a continuous right away. It's going to be this function is continuous. Now how to look like and how to write down correctly. Now see the example, right? If they say without graphing, okay, this question we don't need to graph yet. Show the function of f of x equal to this is continuous at x equal to 3, right? So then this one, the first step is go the first one here. Actually, this is almost the same idea when we do the previous lesson, beginning early lessons. We use the 3 step, remember? If you replace x equal to c, like in this case, you replace x equal to -3 in there. If they come out 0 over 0 or infinity over infinity, you remember? Then you go second step to simplify, right? To simplify it. If simplify, you can simplify, then you replace x, the value of x right away and get answer. If you couldn't simplify, then the next step, you remember, we use properties of limit, right? Use property of limits. Or you can use the two-sided limit. And another thing is, the third one is what? Table. Actually, when you use table, it's like a similar with the two-sided limit. Similar, almost, I think can say it's the same. Two-sided limit. Okay, so there's almost the same meaning. Only the table you're gonna draw in a table like a XY. Remember, use a table XY. But two-sided limit table like from the left, from the right. Okay, from the left like a negative and plus approaches to X, right? But if two-side limit, you just like limit from like this one, c minus, and then limit f of x, right? When x equal to c plus something on minus and plus right hand limits, and I mean minus the left hand limit, and the plus here on the corner of c is a right hand limit. Okay, so almost the same. Okay, in this case, the same idea. Only you include only after you conclusion or kind of thing here. You just answer is continuous or discontinuous. Okay, now we start to see this one. If we do start from the number one here, the first one here, number one, you just do by replace x equal to 3 in the question right away. So I will write down here. So they are almost the same idea, okay? When you, at the beginning, you understand up to here should be okay, I think. So x minus 5. So then after this one, you do the first step right away, okay? Now we do the first step. I will use this green line here. So the first step here. So you're gonna write down f of x when x equal to 3 equal to, and then you replace it right away. -3 plus 1 over -3, -5. Then you simplify this one, become 9 plus 3 plus 1. So you have square root 13, right? Over -8. Okay. So then this one, if you convert to decimal point, it approximates to decimal point approximate -0.451. Okay. So we got the first condition now. Now we go to work for the second conditions. Okay. The second one, you have to, we're gonna find limit f of x when x approaches c, it exists, whether or not, right? So now in this case, you have to, we have many ways to do. First one, you can use first, you have to simplify this one first, right? Okay, and but this one is already simple term, right? So we can pick either, we can do by either property of limits or two-sided limits. Okay, so we are gonna show you both. First one we do by property of limits first. Okay, so now after this one, before this, I will form the question. I take limit both sides first. Okay, so I will take limit both sides first for the writing correctly. Okay, so x approaches -3, and then equal to limit or lim square root x squared minus x plus 1 over x minus 5 when x approaches -3. Okay, equal should be somewhere. Okay, then if I want to use property or limit, so this one, what I have to write down, become, you can write either way here, okay, limit square root x minus x plus 1 when x approaches -3 over limit x approaches -3, and this one becomes x minus 5. Okay, so you can write in that way. So equal sign should be here. Okay, then after this one, you can replace x equal to -3 right away, or you can write, or okay, you can write in this way. It's the more detail, right? But more work to write down. So limit x squared x approach -3 minus limit x approach -3 plus limit 1 x approach -3 approaches. Okay, then I erase this one. This one, oh, okay. Then over limit x approaches -3 minus limit or lim x approach -3. This one equals sign. After this one, you just replace, right? Because you use property of limit already. Can be either this one or this one, okay? When you're writing, for writing show your work. So after either one here, then you replace x, right? So if this one gonna be -3 power 2. When you replace the number, don't forget limit word. Don't need to write anymore, okay? So minus -3 plus 1, limit constant 1 is a 1, okay? So over, this one gonna be -3, -5, then we have what, 9, right? 9 plus 3 plus 1, again, square root 13 over -8. Then this one approximate, okay, become -0.51. Okay, when you see this one is same, right? You see this one. When you do for the second one, you get the same answer, right? With the first condition here, you get the same answer, right? So when you have 1 and 2 equal, correct? This and this equal, then you can conclusion step 3 is you write down, say that condition 1 equal to condition 2. Then finally, this one you can say function f of x square root of the x squared. Just write down the equation minus plus 1 over x minus 5. This function is continuous. Okay, because this get to value of to a same value. Okay, it's equal to -0.4. This one 0 -0.451. Sorry here. Okay, so they are equal. This one you show by this second step here. You do by property of limit. Okay. Okay. So if you want to limit, how to work on. Okay. So again, you have to write down like this one, limit f of x, okay, when x approaches -3, then you do the 2 condition. This one gonna be limit f of x when x approaches -3 plus, okay, to the right hand side of limit, and then this one limit f of x when x approaches -3 negative to the left hand limit. Okay, after this one, you just lay down. Okay, this one I have to, for example, I draw on the number line, right? This one -3, correct? So if I want to work from the right hand side limit first, see, have to form here, right, to the right hand side. So you see what number of x is really, really, really close to -3. So I will, this one gonna be what? -2.9999 or 9999. How many 9 up to you? How many digits after decimal is up to you. But it's an approach, closer to negative x equal to -3. Okay. So this actually is the same like a usual table, right, everyone? But you show only one number approach really, really, really close to x equal to c. Okay, so we don't need to use a table in this case based on log time. Yes, but we use the two-sided limit method. Okay, now this one gonna be from the f of x by this one. So you replace it in with this one, become -2.9999 power 2 minus -2.9999 and plus 1 over -2.9999 minus 5, right? So you see, when you use the calculators, this one you will have approximate decimal equal to -0.451. You can try use your calculator, okay? Now go this one, when negative here. When we use for this one, right? For the negative to the left hand side limit, this is a negative, okay? This is a -3. Okay, so you replace now from here, from the left, correct? Left hand limit, so have to be go this side. So to the left hand, the x is very close, or apples closer or near to x equal to -3. So that means it's what? -3.0001, right? Okay. So this one, when we use the 4 digits, because this one use the after decimal point 4 digits, and this one should be 4 digits after decimal point also, okay? Because when the number is gonna be close to the answer. So now you replace again in the question, to the functions, gonna be -3.0001 power 2 minus -3.0001, and then +1. This +1, okay? And then the whole thing over, -3.0001 -5. Okay, so then you use calculator again. This one gonna be approximate. You will get 0.451. So this same thing, right? This one you do by two-sided limit. And this one you use by the property of limit. Number 2, properties of limit. Okay, but then they come out with the same value in any way. The final, this question anyway is what? Continuous function. Okay, I think that's all. You can do the question, you check in GC, okay? See you next class. Bye-bye.